So with disaster recovery is actually a subset of business continuity, and this is something that tends to be kind of overlooked. Business continuity is about how you keep your business running. So it covers a lot more topics. Business continuity, for example, can include having a high availability cluster to make sure that even if you're applying an upgrade or a patch to Windows, that the system doesn't go down. An example of this would be like Windows clustering services or Exchange database availability groups in Exchange 2010 for keeping your system running in the event that you have to apply Windows updates, which, every first Tuesday of the month we all cringe at, like, gosh, I really hope this is going to work and not cause me some kind of a problem. That's more of a business continuity type of a solution there. Business continuity meaning how do you keep your business running all the time? And so within that definition, you can imagine that disaster recovery falls under that category of how do I keep my business running all the time, and what does that really mean? So disaster recovery differs from business continuity, and it's really only a small subset of business continuity. It's really talking about how do I keep my company running in the event something serious happens, something relatively catastrophic. And by relatively catastrophic, what I mean is that people tend to think of things like hurricanes, tornadoes, earthquakes, really large-scale disasters. But the reality is, and this comes from quite a bit of experience now, things like large-scale power outages are really common. The incidental effects of big storms or heat waves can cause problems, and so it's not always about catastrophic disasters. Sometimes it's just about really painful problems in a particular region. We'll talk about what the key objectives of a successful plan are. We're going to talk about how to customize your plan to meet your specific company's needs. So why do you need a DR plan in the first place? The reality is that every company out there, regardless of what your revenue is, regardless of what your cash flow is, how much cash you have on hand, will suffer some kind of financial loss if you have a system that's not available. The factors that play into this is how long of a loss can you sustain, and how much does that loss cost you on some sort of unit. So for example, if the unit of time is an hour, how much per hour is that going to cost you if you're not able to complete transactions, or if you have employees who are on the payroll who can't work, how much does it really cost you to be down? You need a DR plan to reduce your disruptions and to protect what you have. Data is really valuable for something that is so sort of transient in nature. It changes all the time. It's it's really a bunch of zeros and ones on a disk ultimately. But the reality is that the data that you have has value to it. It has value to your business. Having a DR plan can lower your insurance premiums depending on what kind of a vertical you're in and what kind of insurance you're carrying. So it's really an important way to save some money that way. And you can limit your legal liability as well. So let's talk briefly about the planning process. The first part of the process really is to establish a planning group. So what does this mean? I can't emphasize this enough. What I'm about to say is a super important facet of this. And I'm not sure how many of you in the audience are IT administrators, but I'm presuming that most of you are involved in IT in some way. The biggest mistake an IT director, manager, CIO can make, anybody in IT leadership, is to assume the planning group is IT specific. In other words, to plan for a disaster, I need my IT staff and we're totally responsible for this exercise. That's actually the wrong answer. It's the wrong answer in every way. The reality is the planning group needs to start with the key business decision makers. So even though IT will ultimately be responsible for the end result, they'll ultimately be responsible for the deliverable, and IT will ultimately typically be responsible for the how. So sort of the how and the what, the when and the why. Making the decisions about the what and the why and the how often needs to come from the people who make the business decisions. And it really needs to come from them to decide what systems get protected, what systems are the top priority. Another huge mistake that people tend to make in disaster recovery planning is that they try to, as we call it here, boil the ocean. Instead of starting small and trying to pick the most critical systems to start with, they tend to try to cover everything. Like, what would it take to have my entire environment running in the event of a disaster? That may be an applicable situation. That may be a situation where you say, you know what, I really do have to have my entire environment running. But let's talk for a second about what the drawbacks to that are. One of the biggest drawbacks is that you're going to have a tendency to completely overscope the project. and then never complete it. So by having a planning group, you can actually focus in with sort of laser focus on what needs to be protected, what systems really are business critical. It's a business decision. In my personal experience, for example, I had a head of one department who said, my absolute most critical system is this, and I can't be down for more than an hour. And so I came up with a plan, and I had it all costed out and budgeted out. And I came back with it, and he said, great, I'm going to take this up to my boss. And he takes it up to his boss, and his boss says, you know what, that's not that important of a system to me. I'm pretty sure we could live without it for a week. And so, you know, it kind of set his priorities straight, but then it also was a little bit revealing to him that, like, hey, you know what, actually, according to the real core business, we could live without this system for about 3 or 4 days. His boss actually said the real system I'm worried about is this other one, and so then we had to go back to the drawing board and plan out how to protect a different system. The planning group needs to consist of people other than IT. It needs to, once you've identified your key applications that need to be protected, you need to prioritize them. So, for example, you know, maybe your document management system or your email is the #1 system. Once you've identified your key systems, you need to include people who use those systems to understand how to plan it out. You'll need their help in making sure the application works when you're doing your testing. Another reason it's good to have a planning group is that it's really easy to overplan on if, for example, you're going to do it yourself. You want to build a second site, you want to do all of the work associated with that. The reality is that do-it-yourself DR has a sort of a minimum buy-in cost. And this will resonate, what I'm about to say will resonate with a lot of you from the standpoint of getting budget. And that is that if you overscope, if you're scoping the project and you're saying, you know, Mike, I understand, I hear what you're saying, I really want to keep the scope to something that I can actually do, but the problem that I have and the challenge that I'm facing is that I can really only go to the pot for money once. And even though I'm going to start with this critical system, I know if I do DR myself, it's going to cost me, I've got to buy this, 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 and this, and that's going to cost me about 6 figures or more, or whatever. You've probably got a number figured out. And I know that if I have to go back and ask for more money later, it's going to be harder to get. So I really only want to go to the well once. The reality of the matter is that having your business experts in on this planning process will help them understand what the challenges are. It'll also help them understand, for example, why leveraging a cloud provider for something like DR is such an important option to you, because it allows you to scale into it instead of having that initial capital expense of trying to buy a bunch of equipment and then, you know, set up a secondary site. So part of what you're going to need to do is perform a risk analysis. What does that mean? I mean, it sounds really intimidating, and in fact, you can hire companies to do nothing but come in and do a risk analysis for you, and you can pay them a lot of money to do it. But you're probably thinking, in fact, if you're listening to this webinar right now, you're probably thinking, Mike, that's why I'm listening to this webinar. I don't want to do that. Risk analysis doesn't have to be that complicated. Once you've identified the systems that are really critical to your business, the next step is really identifying what is it about them that's critical. For example, if you're an online retailer and you're selling and you have 100 transactions per minute, let's say, and you know what the average transaction size is, then your risk analysis is to know, based on how long a system would be down and during what time of day, how much money would I stand to lose. This really helps in the budgeting standpoint because it helps you develop your cost of goods sold. So you can factor in your disaster recovery costs with your cost of goods sold and say, hey, you know what? The reality is if I don't have a DR plan, it's going to cost me this figure. If I do have a DR plan, it's going to increase my COGS by this much, but the fact of the matter is that it offsets it by limiting the amount of risk that I have. So a risk analysis doesn't have to be super complicated. To put it on a different solution, let's say that it's not something that's directly revenue generating. Let's say that it's just a core system that you use. It's like the hub system of your company. Everybody touches it. Your risk analysis could be as simple as coming up with an average salary, figuring out, you know, who can't work when that system is down, even who can't work at all, for example, if that system is down, and then just running the numbers on a cost per hour basis and figuring out how much does it cost you per hour for that system to be down, and then that will give you some perspective on how much of a budget you can really allocate and what that does to your costs, what that does to long-term budget planning. The reality is that disaster recovery planning is going to be an operating expense no matter how hard you try to make it a capital expense. It's always going to be something that's going to be an operational cost because the impact is operational. So the impact of a disaster is an operational expense as well. If you're down, it's affecting your operating costs. Your operating costs are affected either because you're not bringing in revenue or because your costs are somehow increased by trying to recover from the disaster or trying to scramble to figure out what you're going to do. So risk analysis doesn't have to be rocket science. It definitely can be. But I want to emphasize that a lot of the times the reason companies hire another party to come in and do it at great expense is largely because they have some kind of political issue in the company where they need priority. In other words, they need an outside company to come in and say, no, really, your IT staff isn't crazy. This really is your risk, or this really is the number. Sometimes IT needs help. So sometimes you need those outside bodies to come in. Again, establishing priorities, I think we've covered that. Developing your strategy. So for example, mapping out, if we've identified 3 systems that absolutely need to be protected and all 3 of them are down, which one do we go to first? Which one comes up first? What's the hardest one to make operational again? Or maybe all 3 of them need to work. Where are these people going to come from that are going to make it work? Do we need to have consultants on call? Do we need to have a trusted partner that we can work with to make sure that this is going to work? Documenting your plan. Documentation, I think probably 100% of my experience in IT, documentation has been something that everybody would say they're lacking most of the time. And in a disaster, documentation is particularly important for the simple reason that you want to have created your documentation while you're level-headed, while you're not in a panic. Having been through some disasters with customers, I can tell you from experience that everybody loses their head a little bit in a disaster. There's a panic level and nobody thinks clearly. As much as we like to rely on our own minds and think that we are absolutely going to exhibit perfect solidarity during a disaster, the reality of the matter is that you're usually sleep deprived, you're usually under a lot of pressure, you're usually fielding phone calls, other forms of communication to try to coordinate what's going on. And if your plan is documented, this is a much simpler process for you, because what it allows you to do is to have a reference point to say, hey, look, you know what? All I have to do is read this document, and we'll follow the document. We may have to deviate from it a little bit because of a special circumstance, but ultimately our plan is documented and we know what to do. It can even be as simple as you would be surprised how quickly people can't find someone's phone number in a disaster. It's that simple. Documenting a plan is like, whoa, I can't find my top IT guy's phone number. It's really, having the documentation is a big deal. Testing your DR plan is critical for a couple of reasons. So there's 2 terminologies that float around a lot in DR. One of them is recovery point objective, which just covers the amount of data you're willing to lose in the event of a disaster. And this affects things like how often you you take snapshots, and how quickly you need to get those snapshots off site. But the other one is recovery time objective. While you're planning your disaster recovery plan, at some point the concept of how long will it take to get these systems back up and running and how long do we need it to take will come up. Most business people will understand, for example, that the faster the system needs to come up, typically the more it costs. Now with cloud solution providers like nScaled, that's not necessarily true. We can certainly keep the costs a lot lower than a do-it-yourself plan for getting your systems back up and running quickly. But you don't really know the recovery time objective. Keep in mind that the O in RTO is objective, not actual. You can't know that your objective is meetable until you've tested it. And it's a really important part of it. Being able to test your plan is absolutely critical. If you're doing do-it-yourself DR, you need to design the test environment into your plan. And it needs to be something that can be done during business hours with your IT staff having level heads, with people ready to take documentation. Testing cannot be overemphasized. And then there's implementation. So once you've got a plan, how do you implement it? What's going to be your budgetary requirements? How do you get everything that you need? The benefit, again, to cloud service providers is we have the ability to give you elastic resources. So implementation is a lot simpler overall than trying to build something from scratch. And then maintenance. How do you know, for example, that your snapshots are getting off-site and that they're usable and that everything is within its RTO or within its RPO for a given day? Maintenance is kind of critical. It's a very critical component of this as well. So the disaster recovery plan, sort of a checklist. You should have an introduction. We call this at nScaled, we call it a run book. It's not uncommon to hear it called a run book, but your disaster recovery plan should include an introduction, and the introduction should really be sort of the business logic behind the disaster recovery plan. Again, your documentation is critical in knowing the reasoning for why the plan was put together and why it was prioritized the way it was can be helpful, more so than you might think. knowing what your business logic was for having a disaster recovery plan will help you when you need to have a cooler head, when you're under pressure and you need to understand. To give you an example, we had a customer going through a disaster, and they had the particular site that was down had two main applications, email and document management. And as we were working on getting the document management system, or actually the email system up and running, I remember sort of observing that even though they had a run book, there was actually nobody suggesting that we simultaneously activate the document management system. And so I remember mentioning to the customer, and I actually happen to know that this customer had different IT resources for email versus document management. I said, is there any reason why we can't start activating document management while we're activating Exchange? Because their Exchange admin was doing a bunch of Exchange-specific work. And they were like, no, you're right. And it's kind of funny. It's like with that sort of introduction of the business logic in there, you can get it in your head that, like, email's top priority, then we need to get document management going. There's nothing to stop us from doing those in parallel because they're both super important. So framing your own document or your own disaster recovery plan is nice. Having the business logic in there is nice. Why you're doing it, what it's there for, and it can even be something nice to go back to later when it's budget time and say, hey, Mr. CIO, unless you're the CIO, or in case you're asking the CFO, hey, this is why we need a budget. This is our business logic. We've all documented this. We all agree on it. Roles and responsibilities. So, for example, who's the key point of contact? You may actually, most of the companies that I've worked for have some kind of a disaster recovery plan as far as people goes. It's usually an emergency response plan. Most companies have them for insurance reasons. And you always have, for example, somebody who's going to be point. So they'll have, like, for this section of the building, you all want to check in with Judy over here. And if you're in this section of the building and something happens and you run outside, you all need to check in with Sam. Roles and responsibilities are really important in those sort of emergency things because you want to make sure everybody's accounted for. The same thing holds true for IT. In the event of a disaster, who does everybody call? Somebody in your team is going to want to be a point, and you're going to want to have some kind of a hierarchy for who is the point guard for this to make sure that everybody knows who to reach out to in the event of a disaster. Maybe one of your top engineers notices it's down. You'd be surprised how often it happens that the top engineer notices it down, panics, and forgets to just starts working on it or figuring out what to do without contacting somebody responsible. It happens because, again, you're panicked. Something bad is happening. Contact information, I mentioned this earlier, is absolutely critical. Our runbook set, for example, the template that we have for runbooks has a contact information section built into it to remind our customers to collect that information and have it and keep it current. Because, again, will you be able to find it in the event of disaster? You might think, oh, my address book on my phone has that, and you know what? Lo and behold, the disaster happens, and you're like, you know what? That's an old phone number for that person. Or, oh my gosh, I didn't know that I didn't have the area code, and it turns out that their phone number is in a different area code, and I don't know what that was. Having all of your team's contact information is critical. Additionally, having trusted partners. So, for example, a lot of companies can't afford to staff redundant people. I mean, that's not uncommon at all, right? You might have some routing guru or a virtualization guru or an email guru. And you're thinking, yeah, I can't really afford to have two of them, and I can't really have 1.5 of them either because my people are already overburdened. How do I get this skill set? Like, how do I have a skill set available in case something goes wrong? And the best answer I can give you on that is to have some kind of a value-added reseller or a partner that you work with that keeps those skill sets on hand. The benefit to this is that you have somebody else you can call. So let's say in a disaster, you can't, for example, count on the fact that your people will be available. It's nice to think that they will be, and we all hope that everybody will be okay, but they may not be available. They may be dealing with family issues or emergencies. They may be unable to connect to any kind of resources, be it phone or internet. It's important to have a second tier of people to contact that are already familiar with your environment, and the most cost-effective way to buffer yourself on that is to have a managed service provider or a trusted partner that you work with that has documentation of your systems, can come in and assist you in the event of a really bad scenario. On the incident response, who gets notified, what is the actual response? The most important thing to do when a disaster happens is to actually group and talk for a moment. It's really good to sync up and set your priorities. So you want to document, for example, when an incident happens, what are our priorities? Let's say, for example, it's a large regional power failure. You may not want to fail over to your DR site. Maybe you want to wait. Maybe you want to say, you know what? Let's find out from the power company what's going on. Maybe it's only going to be a couple of hours. You always want to make sure that you have a clear head and stop and have a sort of response plan and an agreed meeting point or way that you can get in contact with each other to make some decisions. Once you've decided that you're going to activate your disaster recovery plan, then you need to have an actual plan to activate. So you need to have some steps that you can follow. You need to have your priorities already set. One of the interesting things that we've always learned when we test with customers for disaster recovery is that they find some system that had a config file that has to have something changed in the event of a disaster. Maybe it was pointing to an IP address before, it needs to point to a different IP address, or maybe it was a DNS name, but somebody had a host file entry, and it was causing that host to not behave properly when DNS, it's supposed to use DNS and it's using the host file instead. It's all kinds of interesting things you find when you're testing, which is why I can't overemphasize testing, but activating your plan and knowing that it will work is really key. Once your main systems are back online, having a plan for returning to normal operations is also key. And this is not necessarily something you can easily document. It's really just important to keep it on your checklist of things to do. So when we are going to return to normal operations, who do we meet with? Who are the key stakeholders, and how do we get together and make a decision about this? Again, your business priorities are the most important piece of this. Do we fail back immediately? Do we wait and make sure that things are stable? As an example, you might have a disaster that everything appears that it's back online, but then lo and behold, the power grid is not actually stable yet, and it goes back down again in 24 hours later or 5 hours later. You don't always know. Do you want to go back to that? Document history. Maybe you have revisions of the document that contain something that was relevant at one point that didn't seem relevant later. If you can keep versions of your responses, that's always good. Sometimes it's nice to have the logic there as well as any information that may have been captured at some other point in time. Of course, there's the procedures. There's the testing. Believe it or not, how you test your DR solution should really be in your disaster recovery plan. Your plan should include how often you test, what your testing objectives are, and what your success criteria are. You should be able to walk away from a disaster and say, we had 5 success criteria, we met all 5. And then appendices really covers anything that's unique that you discover. So, for example, with the host file example, usually a host file is something you're going to fix, but the config file example, if you know that a certain file has to be changed in order for that application to work on a different subnet for your DR solution, for example, then it's good to capture that and make sure that you have it in an appendix. Another thing that can happen sometimes, for example, is you might have a Windows cluster that has to be brought back a certain way. It's unique to other things. As an example, with nScale's runbook, every server can be activated using the same 5 steps. But ultimately, there are some servers that you will find in your own environment that due to the application, they need some extra help. That's why there's always an appendix in our runbook to help with that. I actually gave an entire webinar on this slide, but it's really important to talk about this stuff. So 5 common mistakes to avoid in developing your DR plan. The first one is SAN-to-SAN replication. And the thing to avoid is oversimplifying SAN-to-SAN replication. When people are talking about putting together a disaster recovery plan, I'm usually very surprised at how often they think that moving their zeros and ones from point A to point B is the hardest part. It's actually the easiest part. Everybody does it. All the SAN vendors pretty much do some type of SAN-to-SAN replication anymore. That's not the right question to ask. If you're buying a SAN to do DR, or if you have a SAN and you're looking at getting a second SAN for DR, or if you're looking at a cloud provider, getting your zeros and ones from point A to point B is not the hard part. The hard part is how much does your data have to change to make that work. To give you an example, probably everybody anyway who sells, all the major SAN vendors anyway, sell a SQL agent. And they'll say, hey, you can snapshot your SQL and replicate it to the other site so that you can make sure that your SQL will work when it gets to another location. What they don't always tell you, though, or it doesn't come out until you get to an implementation, is that SQL database has to be sitting on a LUN by itself on the SAN. So you might have it in a VMDK right now. You might have it on direct attached storage. You may not have. You probably don't have it on a dedicated LUN. You need to move it to a dedicated LUN for their snapshot agent to work. In other words, SAN-to-SAN replication is not enough. There are caveats. There are things you have to look for. Remote co-location choice. This is where our friend Keanu here is making this profound statement. I've actually run into this many times where in talking through disaster recovery plans with people, they've said, well, we've got this colo that's about 5 miles away, and it would be perfect for disaster recovery because our people can just go to the colo, they can get the whole thing up and running again. That only works in certain kinds of disasters. There are many. It may work for you, it may not work for you. It depends on what your risks are, which is why a risk assessment is so important. Is your biggest risk massive regional flooding? Then having a co-location close to your primary site is a bad idea. Is your risk massive power failure? Like the East Coast, I just read an article yesterday that said that the East Coast infrastructure is not going to be able to handle a lot of heat waves, and the power grid basically will fail. Is this colo going to survive? Can the colo provider tell you with all certainty they will survive a massive extended power failure or not? What's their track record on it? Have they been able to do it? The reality is putting some distance between yourself and your recovery site has some benefits. There's another benefit as well. If you need to go on site to activate your disaster recovery plan, that could be a problem. What if the roads are blocked? What if you can't get there? It's better to design your DR plan around not having to physically be at your DR location, which is obviously a great thing to have a cloud provider, which is why I'm talking about it. But the reality is when you think about it, if you plan around not being able to physically be there, you will have a much easier time in the event of a disaster because you will have been already planning around not being physically located there. It's much smarter not to plan on that. And if you're using tape as backup, you can already see that you're in big trouble. If you're using tape for backup and you're sending your tapes off-site and you're going to recover to another site, and I'm telling you that physically going to the site may be a really horrible idea, right there you can already see there's a big problem. Hardware and software drift between your DR site and your site. So, for example, are the processors in the compute nodes that you have at your DR site, let's say you're doing heavily virtualized disaster recovery site, are they of the same family such that you can actually do like resource redistribution? You can move a server from one side to another. Will you be able to, in other words, to vMotion them? Will all of the features you're expecting to work actually work? Are you keeping all the software at the same level? All of these features are really important. Is your switch firmware at the same level? Is your router firmware at the same level? The problem with maintaining your own DR site 9 times out of 10 is that if your people are not, or they're already busy maintaining one site, maintaining another site is extra work. Failed testing is another common mistake. We have had several customers come to us and say, you know what, I'm actually coming to you because I spent the following budget on setting up a DR site. We went to test and we failed. And the problem was, there were two problems with this. The first one is they'd sunk a bunch of costs into the testing. So, I mean, into the DR plan. So they spent money to build a DR site instead of the planning, but this is the part that gets them. So you're probably hearing what I'm saying right there and thinking, okay, yeah, sure, Mike, thank you, Mr. Obvious. That really doesn't help me, but wait for point number 2. The reason failed testing bit them is because they did not have the human resources to respond to the failure. So they had a capital expenditure spent on getting a DR site up and running, but then they did not budget enough human resources to respond to the failure. In other words, their IT staff presumed it would work. And the quote that I like to throw out there is, and then anytime you're in a meeting, hopefully this will resonate with you, anytime I hear the words come out of someone's mouth when they say, all we have to do is, I immediately raise a red flag. I can't tell you how many times in my career I have heard IT people say, oh, all we have to do is, and I can promise you that with a high degree of certainty, every time I hear those words, somebody's oversimplifying something. So the fact that people couldn't respond with the human resources needed to respond to the failure is a huge problem. Underestimating resources is the 5th. This goes into what I was talking about earlier, that you cannot assume your staff will be available. You can't assume that the people who make your stuff go on a day-to-day basis will be available in a disaster. Who do you have that can back you up? And like I said, my recommendation for you on that is to find somebody you trust to work with that can have the documentation, be ready to roll in the event of a disaster, and support you. One of the nice things about working with a third party is that they come into your solution, they come into your environment blind. And remember how earlier I said documentation tends to be the biggest lapse in most IT shops. Well, the nice thing about bringing in a third party is being your backup for a disaster is that they're going to ask you for documentation. They're going to want to know what it is, and they may even help you develop the documentation. They probably will help you develop the documentation because they're going to want to know in sort of their own terms how it should look and what it should include so that they can support you. How do I get started? So the most important thing is to gather input from your leadership. Again, this is not an IT alone effort. It's the biggest mistake you can make if you're coming up with a DR plan to think that IT has to go it alone. The reality is that you do need somebody else to tell you what systems take priority. Nobody wants to take responsibility for that type of decision if you were totally and completely wrong. You know, if you did it in a vacuum, you made a decision, these are the most important systems as far as I'm concerned, without input from the business leaders, ultimately you have to answer for it later. It's kind of rough. So it's better to just include business leaders. It helps you get budget. It helps you scope out how, you know, what the actual undertaking entails. It helps you not absorb the soft costs of your staffing quietly. It's way too easy as an IT leader to quietly absorb soft costs from your IT staff taking on extra work. By involving upper management in the decision process, understanding your risk, understanding your real costs, it's much easier than to have that discussion about we either need to staff up or we need to bring on some contractors we can trust. Creating a budget is obviously key. Again, you need buy-in for that. You know, most of the time your budget will not cover what you already have for DR, or maybe the budget was fairly arbitrary or wasn't taken into account within an actual reason. You know, get some quotes, find out what's going to be required. Review your vendors. The bottom line is that you don't want to go to your vendors and without some kind of an idea of what you need. So going to disaster recovery vendors and finding out what your real needs are will help you to pick the right vendor. So you can actually have your checklist of things you need it to be able to do. For example, System A provides services across the internet for all of our customers. Therefore, one of my requirements is I need an internet address in a disaster, and I need to know how to change the A record or what I need to do to make that application fail over to the cloud. So now your checklist includes things like I need internet. I need people to be able to access me from the internet. I need to be able to have DNS working. You know, you have a checklist. You can go to them with some goals. And just you know, for the final slide here, talking about us, nScaled, we're a company committed to disaster recovery. We really give you disaster recovery and backup and long-term storage in a seamless product. It's all delivered through a SaaS console. We have industry-leading recovery times. A typical server recovery time for us is about 10 to 15 minutes. You can get a server back up and running, and you can serialize that so you can activate more than one server at the same time, start firing them up, getting them going. We can take snapshots on a periodic basis. We have some customers taking snapshots of servers every 10 minutes. And while that may sound like it's an unachievable goal, the reality of the matter is it works very well because of the way that we handle compression and the way that we handle our super efficient replication technology to get it across the wire to the cloud. nScaled, we've taken security very seriously. We're very serious about our multi-tenant architecture. We built it multi-tenant from the beginning. That was one of our design objectives from the get-go. So it's a very well-done solution. It's something that you can feel comfortable with. And if you look at our client list, you can understand that people like these companies would not have gone with us if they didn't think that they could trust our architecture. We're more than happy to talk about our architecture. I like to say we're the least cloudy cloud company you could possibly do business with. We actually talk about the way that we do things. We don't try to hide how we do our practices. So you can feel comfortable doing business with us. We give you one SaaS console for web-based management for the whole solution. We have testing that can give you during the business hours, during the regular workday testing that doesn't affect your production environment. We have 24-hour-a-day customer service. So give us a look, and feel free to give me an email or give our sales department an email. We'd love to talk to you. If you're working through a channel partner, by all means, work through the channel partner. Let's have a discussion. You can reach out to us directly and let us know who you're working with, and we can have some discussions. With that, I'll pass it back to Sarah.
Great, thank you, Mike. Okay, do we have any questions? If you've got a question, go ahead and type it into the question panel right now, and we will answer it. We've got a few so far. Let's see, the first question is from Jim. He wants to know if a link will be made available to download this presentation. And yes, Jim, and we're actually recording the webinar, so we can send you a link to the whole recorded webinar later today. Then the next question is from Sheila, and Sheila would like to know, her phone was cutting out a little bit, and she would like if you could talk about failed testing really quickly. We'll review.
Yeah, so failed testing came into one of the 5 things to avoid. five common mistakes that you need to avoid. And so the biggest problem that I've seen customers have with field testing is that they've tried to do it themselves. We've had customers come to us, in fact, they've spent all the money to build a second site, and they went ahead and got to the point where they're testing. They went through their testing and it failed. The problem with failed testing, so first of all, you have this capital expenditure that you've put out there. You've gotten the budget. Somebody has to answer for that budget, right? That's the hard part. I always, can see the panic or hear the panic in the person's voice who got the justification for the project. The thing that killed them, though, was not just that testing failed. It was that they did not have the staff to recover from the failure. In other words, they failed. They don't know why they failed, and they don't have enough resources on staff to actually figure out what failed. And that's the biggest mistake that you can make in terms of testing, is that you actually don't have the time to troubleshoot your own solution to figure out what went wrong. So failed testing is something that you can avoid by using a solution like nScaled, for example, where you can test during business hours. The test environment is supported by the company providing it. That makes it a lot easier to test it, and it was designed up front. You're not having to design your own testing solution as well as your own DR solution.
Okay, and then Carl has another question about DR testing. He wants to know, how can you fail a DR test when the purpose is to uncover gaps and then fix them?
So the reality is that every test has an objective. It has a set of clear objectives. And let's say that when you're coming up with those objectives for your DR test, that you have 5. So we need to get 5 servers up and running. They all have to communicate with one another. We need to establish the correct order, and the service needs to work and perform at the level that it will serve whatever purpose it needs to have. You're correct. The purpose of testing is, in fact, to learn from those mistakes. However, failing any of those means you failed to meet your total objective, your whole objective. Then going back to my previous answer to the question, the other problem is do you have the resources to troubleshoot the failure? So it's failed DR testing, meaning that we failed to make it work the way we thought it was going to work, and now we don't have the resources to figure out why it didn't work or what needs to work. The surprising obstacle that people tend to run into with DR testing is that the person who originally set up the system, for example, that's being protected is gone, or they've forgotten what they did. Maybe it was a smaller company. They don't remember half the settings they put in. Now they're recovering in a disaster, and it's like, I know there's a setting somewhere for that. I don't really know what it is, but now I don't have time to look at it because I've got things that are making money for us right now that I got to go work on. It's really hard to budget resources for that. And the problem is that you can have, if you're doing it yourself, for example, you can have 2 key problems. One of the problems is that you can be troubleshooting something that was a bad design choice on your part. So, for example, you thought you were designing the test mode perfectly, and you thought you had thought of every detail, and it turns out that you forgot something. And so now you failed your testing because, architecturally speaking, something about your test environment didn't work. And the second reason being that even if you thought through your test environment really, really well, you may not have easy access to find out what it is that's broken. So it could take an extra amount of time just to figure out what exactly broke, and you may be chasing the wrong thread. It's just as hard as troubleshooting production systems that have failed. It's kind of the bottom line. How much attention can you really give it is one of the biggest challenges. So yes, you're right. You can learn from a failed test, but the problem is that you may not have enough resources to actually learn from it.
Great. Well, those are all of our questions. So if you have any more questions, please go ahead and email Mike. You can see his email address now, or info@nscaled.com. Thank you, everybody, for joining us, and thank you also, Mike, for presenting today.
My pleasure. Have a great day.